All right, for this next question, we're going to look at a few different periodic trends. And first, and you'll want to do this yourself, I would take and mark up my periodic table and our various trends that we have here. So up in this corner, the atoms are small. Up in this corner, they have a high ionization energy. They have a high electron affinity and high effective nuclear charge. So a small atom, high ionization energy, high electron affinity, and high Z effective. Everything is high up in this sort of corner of the periodic table. And then the far corner of the periodic table down here, and we don't really care about francium because it's so radioactive. There's not a whole lot done with it, but we talk about this corner. Properties are known for cesium. It's large atom. It's the largest of the periodic table. It has a low ionization energy. It has a low electron affinity, and it has a low Z effective. Okay, and so what we see is high values of most things up here and low down here, with the exception of small atom up here and large atom down there. All right, so let's look at our first example then. We're looking for the highest ionization energy of this set, and we have here fluorine, neon, rubidium, and chlorine. Which one has the highest ionization energy? Well, rubidium's way over here, so I'm not even really going to worry about it. It's going to be really low. It's near cesium, so it has a very low ionization energy. Let's just focus on the three that we can try to sort out. So we have chlorine, fluorine, and neon here. So the ionization energy increases this way. So fluorine is larger than chlorine, and ionization energy increases this way. So neon larger than fluorine, fluorine larger than chlorine. And so neon is the one with the highest for this set. The next problem it asks us, carbon, boron, silicon, and germanium, which one has the smallest radius among this set? So let me mark these. Boron, carbon, silicon, and germanium. Well, three of these are in a line, and the size increases as I go down. So the biggest one here is germanium. Germanium bigger than silicon. Silicon bigger than carbon. And then boron is larger than carbon. Boron is larger than carbon because for the left to right trend, because as we go right, they get smaller. So let's write this down. Boron larger than carbon, and silicon larger than carbon. And if we go back, germanium larger than silicon, which is larger than carbon. And so if we're trying to find the smallest, it's definitely carbon. Because boron's bigger than carbon, silicon's bigger than carbon, and germanium's bigger than carbon. All right, and then here we have an interesting set. So let's compare here beryllium 2+, beryllium, and fluoride. So as we go left to right, these get smaller. As we go left to right, they get smaller. So going from beryllium to fluorine, it gets smaller. But we went from beryllium to fluoride, so that's a little bit trickier to figure out what happens, because when we add a charge, this is bigger than that, probably. And so we're not sure between these two which one's bigger. But beryllium is definitely larger than beryllium 2+, because the cation that's formed is always smaller than the neutral atom. So the smallest of all is beryllium 2+, and then a little bit harder to decide what the order is over here, but fortunately the question is asking us what's the smallest. So the very smallest is the beryllium 2+. And then the last one here is asking us what's the atom with the lowest electron affinity, and we're given bromine, iodine, and barium. Okay, which one has the lowest electron affinity? Well, the lowest in the whole table is cesium. Barium's right next door, and so this is actually a pretty easy one. Okay, barium has the lowest electron affinity of any of those.